What is up, everybody? Neil here. Welcome back to the channel. In this video, I want to talk about my AGI timelines because I'm updating them a little bit, and I'm going to move the goalpost and say, actually, I want AGI to be more powerful than this. Because if you've been watching the channel, you would probably know that my previous definition for myself of AGI has been that computers can now use themselves better than humans can use them. And I think that's going to happen pretty quickly here over the next 1 to 3 years. And I've been saying this for a few months. I said 12 months ago that we would start to see like the first forms of agentic coding agents that are starting to actually be really, really good. And we're starting to see that with 4.5 Opus, and everybody thought I was crazy back then, which is okay. So what I want to do is say, I'm moving my timelines back because I want to see things that are more capable. I don't just want the Star Trek computer, right? Um, and I think whenever we do get the Star Trek computer, which we're kind of already there, maybe 1, 2 years, it will fully be there, and you'll just talk to your computer and it'll do whatever you want. And that's kind of the way we'll be moving forward as a species in the cosmos. um, that's going to be a very profound shift. It's going to help a lot with scientific discovery. It's going to solve software engineering and the biological and the computer form of software. And it's going to be profound. It's going to be extremely profound. Now, the thing that I do want to say is I've kind of updated my mental models as to how intelligence is formed. And for a true AGI that is like, whenever I think of AGI, it does all of the things that humans can do and better. Which some people might say that's super intelligence, which isn't a bad argument. That could be super intelligence. But let's say engineering things from the first principles of electrons upwards. That's not necessarily going to happen with the computer that can use itself. We need humanoid robots for that. What I do think is we'll be able to solve a lot of physics, not solve, but like we'll discover a lot of new things with the computer that can use itself better than human can use the computer, and that'll be very useful. And we'll make a lot of progress. But the thing that people need to realize is you're not going to build a brain without having the proper optimization space. Like, you're not going to build the type of intelligence that we have without having the problem space that we have. You need to have a humanoid robots in the universe that we experience. Because whenever you look at it from an evolutionary standpoint, evolution is basically this reinforcement learning algorithm that is applying selective pressures to our information to fit the problem space of our part of the universe, Earth, right? And that's really what we will need to have the full spectrum of intelligence that humans have, is that type of optimization for the problem space that we're optimizing for. Otherwise, it'll be jagged, right? It'll still be a jagged type of intelligence. And I think the intelligence that we're building in the computer, even though it'll have like a digital harness and it can optimize and fill pretty much all of the spaces of the computer that we could fill, and so much more that we're going to be like, holy shit. Even though it can do that, it won't have like the types of nuances that we could understand through operating as a being in a three-dimensional space, within not just three-dimensional space, but our part of the universe. Because there's a lot of little subtleties that we just kind of take for granted and we never really notice them as we're moving around. Now, the thing we need to realize is there is nothing fundamentally different between us and these computers. Whenever you get down to the first principles of physics, we're just quarks and electrons. Now, as you come up the stack from quarks and electrons, the things that are different is the type of computation that we're performing, right? So the computers have certain types of algorithms, they perform certain types of computation, and humans might perform certain different types of computation. So that's one of the different things that we have between us. And then the other thing is the problem space that we optimize within. We have our human body, which is kind of like the interface that we use to operate within the physical world, and that causes a certain type of optimization, right? The space of problems has a certain shape, which causes the intelligence to emerge in a form of that shape. Um, which is why we kind of have like this more nuanced in these current AI systems. We have like the problem space that we are filling, and the algorithms that we have create a different shape than the current state of AI. But whenever we have continuous learning algorithms and we have active inference in humanoid robots that have similar shapes and sizes to the way to what we have, and they have a similar interface with the world to us, um, it might be, we don't know this, this is still one of those unknown unknowns, but it might be just with continuous learning and active inference, it starts to just emerge the form of intelligence that we have as far as the shape and performance. This could be true, but we don't know yet. Um, because again, now that it has the actual problem space, it'll have the same problem space as us, or at least a very similar problem space to us. The thing that we still don't know is the computational pattern. What type of computation is it actually using, and what is the shape that what is the shape that emerges from that computation? Because that computation, just like the problem space, puts selective pressures on the information, right? Just, I mean, the way you should think about it is biology is all it is information. It's just rigid information. In the universe, evolution is putting selective pressures on our information, which causes us to evolve certain traits. Same thing with AI. AI is just not as rigid as humans. Humans are very rigid. Software on a computer is very malleable. That's fundamentally the only difference. So the two unknowns for like the type of AGI that Demis Hassabis wants, and it might be true, like he says, we might need a handful of breakthroughs to actually get the AGI the way he wants it, which is AI that can perform all of the cognitive tasks a human can, whether it's like imagination, dreaming, all of those different things, smelling, tasting. He wants everything, right? Um, in order to have an AI system that can do all of those different things, it's possible that we might need a new architecture. But we don't actually know. It could be that just through continuous learning and active inference within the space of problems that humans operate within, those things start to emerge over time. Because you'll start to get consistent self, persistent, consistent self over many, many instances, and you'll have the ability to fill the problem space with your continual learning. The problem space that you're optimizing for starts to shape the intelligence that you have. The evolutionary pressures with that reinforcement learning causes it to be a different shape. So at this point, again, it just comes back to the algorithms, the architecture. And this is where Demis Hassabis comes in. And he says we might need some breakthroughs. And he could be correct. He definitely could be correct. But if we do really saturate the problem space with the computer in the next 1 to 3 years, which it seems like we're going to, at that point, maybe we can have enough computation to actually map a human brain. Neuralink's doing some pretty good work on this. Maybe we can map a human brain, and then we can start to figure out the type of computation that the human brain uses, and therefore we can start to model these systems much better after that type of computation, and that's when we start to see actual AGI, which kind of all converges, in my opinion, within 2029. So Ray Kurzweil is an absolute genius. This is kind of where I come and I say I'm done making predictions. My predictions are whatever Ray Kurzweil said. That being said, I kind of just wanted to come on here and mention these few things. Um, yeah, 2029 seems to be where we'll see like the first spawn of what one would call AGI, and then yeah, everything Ray Kurzweil says, I'm just gonna just go watch that.